In August of 1945, when the smoke still rose from two Japanese cities and the silence of surrender had barely settled across the Pacific, America's B-29 Superfortress was the most powerful flying machine the world had ever produced. It had crossed oceans at altitudes where the air was too thin to breathe. It had carried fire to the heart of empire. It had, in the space of 2 missions, redrawn the boundaries of what human beings understood to be possible and permissible in war. But the same month that victory was declared, the orders slowed. The contracts were canceled. The factories went quiet. What happened next? Almost no one remembers. The B-29 Superfortress was not simply a bomber. It was a civilization made aeronautical, a machine so complex, so expensive, so loaded with experimental systems that its development had cost more than the Manhattan Project itself. Engineers at Boeing had spent years solving problems that had never before been posed. How do you pressurize a fuselage at 30,000 feet and still allow a crew of 11 to fight? How do you synchronize remotely controlled gun turrets across a quarter mile of vibrating aluminum? How do you burn enough fuel to reach Japan from the Marianas and still carry a bomb load that matters? The answers came slowly and at enormous cost. Dozens of test pilots died in crashes during development. Engines caught fire on takeoff. Wings flexed in ways the wind tunnel had not predicted. And yet, by the summer of 1944, the B-29 was flying combat missions over Asia. By 1945, it had become the single instrument through which American strategic air power expressed its fullest ambition. General Curtis LeMay stripped the planes of their defensive guns to carry more incendiary bombs and sent them low over Tokyo at night. The fires that resulted were visible from 200 miles away. More than 100,000 people died in a single evening in March of 1945, more than in either atomic bombing. The Superfortress did not merely participate in the destruction of Imperial Japan. It administered it. Then the war ended, and the machine that had defined a new era of warfare was almost immediately a problem to be solved. The scale of American industrial production during World War II is difficult to comprehend from this distance. By the time Japan surrendered in September of 1945, Boeing and its partner manufacturers, Bell Aircraft in Georgia, Martin in Nebraska, had delivered more than 3,900 B-29s to the United States Army Air Forces. Thousands more were on order. Assembly lines that had taken years to build were running at full capacity. And then, in the space of weeks, it was over. The contracts were canceled by the hundreds. Unfinished airframes were pushed out of factory doors and left on airfields. Completed aircraft that had never flown a combat mission sat waiting in depots across the Pacific. The logistics of demobilization were staggering. The Army Air Forces had to figure out what to do with an air force of continental proportions: bombers, fighters, transports, trainers, and do it quickly, for the cost of storage exceeded the cost of disposal. For the B-29, the answer came in 2 forms. Some would be retained, many would be stored, and eventually the vast majority would be destroyed. The aircraft that were retained formed the backbone of the new Strategic Air Command, established in March of 1946. SAC, under its successive commanders, believed, correctly as it turned out, that the atomic bomb had changed the fundamental nature of great power competition, and that the delivery vehicle for that bomb was now the most important military asset on Earth. The B-29 was that vehicle. It was the only aircraft in the American inventory capable of carrying a nuclear weapon to a Soviet target. It would remain so for years, but the ones that were not retained, the hundreds, then thousands of surplus superfortresses, began a journey that would end in the Arizona desert, or in the smelter, or in histories that no one has written. The desert was chosen for reasons that are almost poetic in their practicality. Dry air does not corrode aluminum. The sun that bleaches everything else preserves metal with remarkable fidelity. The flat ground of southern Arizona, near a small city called Tucson, offered space without end and weather without consequence. And so Davis-Monthan Army Airfield, later Davis-Monthan Air Force Base, became the place where American air power went to wait. The aircraft began arriving in 1945. They came in formation and alone, flown by ferry pilots who climbed out of the cockpits, signed the paperwork, and walked away. The planes were cocooned in a plastic spray compound called Spraylat, which sealed the engines and windows against moisture. They were parked in long, precise rows, wingtip to wingtip, in a grid that eventually stretched for miles. From the air, it looked like a city. From the ground, it looked like a graveyard. The Superfortresses sat in the Arizona sun with their noses pointing in the same direction, as if they were still taxiing toward a runway that did not exist. Some retained their nose art, the painted names and figures that crews had added during the war, private mythologies pressed in pigment against the aluminum skin, firebombers and atomic couriers side by side, their histories invisible to the men who cataloged them by serial number and parked them in sequence. Davis-Monthan was not, as it is sometimes described, merely a junkyard. It was an inventory. The aircraft were maintained in a condition of preservation theoretically available for recall to service if the international situation demanded it. Throughout the late 1940s, the Cold War remained young and unpredictable enough that this possibility was taken seriously. The Soviet Union was not yet a nuclear power. American air dominance was absolute, but American planners understood that it might not remain so, and they wanted the reserve. What they did not fully anticipate was what was coming in Asia, and when it came, some of the machines in the desert flew again. The Korean War began on the 25th of June 1950, when North Korean forces crossed the 38th parallel in strength and drove south. Within days, the United States was at war again, or something close enough to war that the distinction barely mattered. And within weeks, B-29s were flying combat missions over the Korean peninsula. They came from bases in Japan and Okinawa and Guam. Some were aircraft that had never left service, maintained by units of Strategic Air Command. Others were drawn from the reserves, called back from the limbo of partial retirement. Together, they formed the Far East Air Force's Bomber Command, and they set about doing what the B-29 had always done, striking industrial targets, transportation networks, supply depots, and eventually, when the conventional targets were exhausted, anything that moved. The Superfortress was 7 years old by the time it flew over Korea. In technological terms, that was an enormous span. The jet age had arrived. North Korea had Soviet-supplied MiG-15 fighters, swept-wing, jet-powered, capable of speeds the B-29 could not approach. The great bomber that had been untouchable over Japan in 1945 was, by 1950, dangerously vulnerable to modern air defenses. MiG-15s could climb above the B-29's operational ceiling, roll over, and attack from above and behind, where the defensive guns had limited coverage. The losses mounted. In October of 1951, a series of disastrous daylight raids over the Yalu River bridges cost the United States 4 B-29s in a single mission, a loss rate that, if sustained, would have consumed the entire bomber force within months. The Air Force responded by shifting to night operations, by increasing fighter escort, by changing altitudes and formations. It was adaptation, not solution. The B-29 was fighting a war for which it had not been designed, against adversaries it could not outrun in a strategic environment it had not anticipated. It flew anyway. It flew until the armistice in July of 1953. And when the war ended, it was, at last, finished as a frontline combat aircraft. But by then, something had already happened on the other side of the world that would give the B-29 a second life it never asked for and could not have imagined. In the summer of 1944, 3 American B-29s made emergency landings in Soviet territory, one near Vladivostok, 2 at bases further west, after sustaining damage during missions over Japan and Manchuria. Under the terms of Soviet neutrality in the Pacific War, the crews were interned and eventually repatriated through Iran. The aircraft were not. The Soviets kept them quietly and delivered them to their most capable aviation engineer, Andrei Tupolev, a man who had spent years in a Stalinist prison camp designing aircraft for the state that imprisoned him. Tupolev was given an extraordinary directive. He was not asked to study the B-29 and draw lessons from it. He was asked to replicate it. Exactly. Every rivet, every instrument, every dimension of the airframe, reproduced in Soviet manufacturing standards and Soviet materials, without modification. It was an act of reverse engineering of almost unprecedented ambition, and it succeeded. The aircraft that emerged from Soviet factories in 1947 was designated the Tupolev Tu-4. It was, to within tolerances measurable in millimeters, an American B-29. It flew with Soviet engines that produced nearly the same power as the Wright R-3350s it replaced. It carried Soviet weapons, Soviet radios, Soviet instrumentation, but its bones were American. Its geometry was American. The curve of its pressurized fuselage, the sweep of its tail surfaces, the placement of its gun blisters, all of it traced back to a drawing board in Seattle when the Tu-4 appeared at a Soviet air show in 1947. American observers initially assumed they were looking at captured B-29s. It took careful study to confirm that these were new-built aircraft, produced in quantity, incorporating what had taken the United States a decade and billions of dollars to develop. Stalin's Air Force had acquired, at the cost of years of engineering labor, the same strategic bombing capability that had defined American power in the Pacific. The B-29 had built the post-war world order. Now, through its Soviet ghost, it was helping to undermine it. While the Tu-4 was entering service over the Urals and the B-29 was flying its last combat missions over Korea, the fleet of mothballed superfortresses in Arizona was undergoing a slow transformation. Some were being withdrawn from storage not to fly combat, but to serve in roles that their designers had never considered. The KB-29 tanker was among the most important. Strategic Air Command's new jet bombers, the B-47 Stratojet, which began entering service in 1951, required aerial refueling to reach their targets inside the Soviet Union and return. The B-29's great internal volume made it a natural donor for conversion. Tanker variants were fitted with fuel tanks in their bomb bays and hose and drogue refueling systems, transforming aircraft that had once carried fire into flying gas stations for the machines that would carry nuclear weapons into the next war. The WB-29 served as a weather reconnaissance aircraft. Crews flew it into typhoons and Arctic fronts, gathering meteorological data that was essential both for civil aviation and for the precise planning of nuclear strike missions, since weather over the target could determine whether a bomb detonated at the intended altitude or not. The WB-29 flew through storms that would have turned back anything less robust, probing the upper atmosphere with instruments that reported conditions no one on the ground could otherwise know. The RB-29 carried cameras instead of bombs. These aircraft flew reconnaissance missions along the periphery of Soviet and Chinese airspace, photographing military installations, tracking the development of Soviet nuclear facilities, mapping terrain that American war planners needed to know in exquisite detail. Some of these missions were provocative enough to draw fighter intercepts. Some drew fire. A few were lost. The crews of the RB-29 flew in a Cold War that was, in those moments, something warmer than its name suggested. Each of these secondary lives extended the aircraft's service history. Each added chapters to a story that should, by the logic of technological obsolescence, have ended in 1945. But the logic of technological obsolescence is not suspended indefinitely. By the mid-1950s, the B-29 and its derivatives had been superseded at every role they performed. The B-47 and then the B-52 Superfortress took over the strategic bombing mission. Dedicated jet tankers, the KC-97 and then the KC-135, replaced the KB-29. Weather reconnaissance passed to more modern aircraft. The last B-29s in active service were retired in the late 1950s. Their serial numbers struck from the inventory, their maintenance records closed. What followed was the scrapping. The process was bureaucratically efficient and almost entirely undocumented in any form that has survived. Aircraft were flown or towed from storage. They were stripped of any components that retained value: instruments, engines, hydraulic actuators, electrical systems. What remained was the airframe. Tons of aluminum alloy, still structurally sound, still aerodynamically coherent, but no longer useful to anyone who required an airplane. The aluminum was worth money. In the post-war economy, raw materials retained value even as the objects made from them did not. Smelters were paid to reduce the airframes to ingots, uniform blocks of metal that would be rolled into new forms, extruded into new profiles, incorporated into new products that bore no trace of their origin. A B-29 that had flown from Tinian to Tokyo, that had carried men through 30,000 feet of darkness over the Pacific, that had been the most expensive and sophisticated weapon system in human history, became, by weight, a quantity of aluminum indistinguishable from any other. The scrapping was not performed with malice. It was performed with indifference, which is a different thing and, in its own way, more difficult to contemplate. The men who operated the cutting torches were not destroying history. They were processing surplus materiel. The distinction was administratively valid. It was historically catastrophic. The numbers are difficult to verify with precision, but the scale is not in doubt. Of the nearly 4,000 B-29s built during World War II, the vast majority were destroyed through combat losses, accidents, deliberate scrapping, and the ordinary attrition of machines that are used hard and maintained imperfectly. By the time the active fleet was retired and the storage yards were processed, the number of surviving airframes had been reduced to a fraction of the original production total. Some aircraft had been transferred to allies. The United Kingdom received a number of B-29s, which it operated under the designation Washington B. Manque 1 during the early Cold War, bridging the gap before its own V-bombers were ready. These too were eventually returned or scrapped. A handful went to other nations. None of these transfers resulted in preservation. The museum community was not, in the 1950s, organized in the way it later became. The Smithsonian Institution's National Air and Space Museum had a collection, but its storage and display capacity were limited. The United States Air Force maintained a few aircraft at bases for static display, but the selection process was informal, the preservation standards inconsistent, and the long-term institutional commitment uncertain. Aircraft were saved almost by accident, by the intervention of individuals who recognized what was about to be lost and acted in time. A base commander who refused the scrapping order for a particular aircraft and arranged instead for its transfer to a local museum. A veterans organization that adopted a specific airframe and spent decades restoring it. A private collector who bought a surplus aircraft before the cutting torches arrived. These were the exceptions. They were numerous enough that a substantial number of B-29s survive to this day. Estimates place the count at somewhere between 20 and 30 airframes in various states of preservation, but they represent a salvage operation conducted against the tide of institutional indifference, not a deliberate act of historical stewardship. Among the survivors, a few deserve particular attention, not because they are more historically significant than those that were lost, but because they demonstrate what survival requires. The aircraft designated Enola Gay, which dropped the first atomic bomb on Hiroshima on the 6th of August 1945, was transferred to the Smithsonian in 1949. It spent decades in storage, partially disassembled, suffering the slow degradation that even museum storage inflicts on aluminum and rubber and fabric. Debates about its display, about the appropriate historical context for an aircraft associated with the deaths of tens of thousands of civilians, kept it out of public view for years. It was not until the late 1990s and early 2000s that a full restoration was completed, and the aircraft was displayed in the Udvar-Hazy Center near Washington. The restoration itself took more than a decade and required skills that barely existed. Specialists in the materials and techniques of 1940s American aviation manufacturing. The aircraft called Bockscar, which dropped the second atomic bomb on Nagasaki 3 days after Hiroshima, is displayed at the National Museum of the United States Air Force at Wright-Patterson Air Force Base in Ohio. It arrived there in 1961 and has been on continuous public display since, a less controversial history than the Enola Gay, partly because its mission, though equally lethal, was less symbolically freighted in American public memory. The airworthy survivors are rarer still. At any given moment in recent decades, perhaps 2 or 3 B-29s have been maintained in flying condition, a number that fluctuates as aircraft undergo restoration, suffer mechanical failures, or are grounded for extended maintenance. The effort required to keep a 70-year-old aircraft flying is immense. The Wright R-3350 engines that powered the B-29 are no longer manufactured. Parts must be fabricated from scratch, sourced from other surviving aircraft, or adapted from related designs. A single flight requires weeks of preparation and teams of specialists, and yet the flights happen. The aircraft take off from grass strips at air shows, climb to altitude, and circle over crowds who were not born when the last B-29 flew in combat. The sound of the engines, a deep, ragged, mechanical thunder, quite unlike the smooth whine of jets, carries across the airfield and settles in the chest. It is the sound of a world that no longer exists, preserved by the stubbornness of a few people who refuse to let it go entirely. What does it mean that so few survived? The question is not rhetorical, and it does not admit of easy answers. The B-29 Superfortress was built at a cost that, in contemporary terms, ran to hundreds of billions of dollars. It was operated by tens of thousands of men, many of whom did not survive the war. It shaped the outcome of the largest conflict in human history. It delivered the weapons that ended one era and inaugurated another, an era of nuclear deterrence and mutual assured destruction that still defines the strategic landscape of the world. The aircraft's influence on everything that came after it, on the design of aircraft, on the doctrine of strategic bombing, on the geopolitics of the Cold War, on the Soviet aerospace industry, on the development of airborne refueling and strategic reconnaissance is incalculable. And yet, the vast majority of them were reduced to ingots. They were melted down and made into storm windows and beverage cans and automotive components. The metal that carried the atomic bombs to Japan became the metal that carries soft drinks to grocery stores. There is no monument to this transformation. There is no record of which specific aircraft were smelted on which specific days. The archive of the B-29 fleet, the complete physical archive, the three-dimensional one made of aluminum and steel and rubber, is almost entirely gone. What survives is the paper archive, the maintenance records, the mission logs, the contract files, the engineering drawings, the photographs, and the machines themselves, the 20 or 30 frames in museums, the one or two that still fly. They are not representative of the fleet in any statistical sense. They are survivors in the way that individual people are survivors of catastrophes, not typical, not selected by any principle more coherent than chance and the intervention of strangers. The B-29 Superfortress was the last of something and the first of something else simultaneously. It was the last great propeller-driven strategic bomber and the first delivery vehicle of the nuclear age. It was the machine that made the modern world in one sense, that forced the redefinition of warfare, of deterrence, of the relationship between civilian populations and military power. And it was also the machine that the modern world unmade with the same efficiency it brought to everything else. The desert at Davis-Monthan still holds machines. The rows still extend toward the horizon. Different aircraft now, different generations, different wars, but the same logic applies. Too many to fly, too valuable to destroy immediately, too expensive to maintain, waiting for a decision that will come eventually in the form of a budget line or a policy review or simply the slow accumulation of years. The archive that survives is always smaller than the one that was lost. The machines that remain are always fewer than the ones that flew. If you found this history worth keeping, there is another American war machine whose story ends in a boneyard, built in the millions, deployed on every front of the Second World War, and reduced almost entirely to memory within a decade of victory. That story is waiting for you here.